Hello and welcome to today's Minitest, lecture 32, vectors. Here is the Minitest for those of you who came here to just solve it. And for those of you who are here to see the solutions, let's get right ahead into it. So, for two vectors to be the same, they need to have the same magnitude, direction, and orientation. So we need to check their length and if they take up the same slope. Well, the direction they point would also be helpful, but we'll get to that. For length, we'll just use Pythagorean theorem. So the sum of the squares of each of the coordinates equals to the square of the length. And we see that both are the same length, because basically, yeah, the sum of the squares. That's a great start. Now for direction, how would we check it? Well, derivatives would surely help, as they tell us the steepness of the slope. So if they have the same slope, that should also be another check mark. As we remember the formula for the slope, it's delta y divided by delta x, and that equals to the slope in a linear function, which vectors kind of lie on, and that is equal to the tangent of the angle between the x-axis and the linear function. So if the ratio is the same, then the vectors would have to take the same angle. Of course, we will use the difference between the components and 0, as vectors are linear and that difference is the easiest to know. Plus, these coordinates are defined as the displacement from 0, so 3 units this way and then 4 units this way. Those are the displacements, regardless of the coordinates, whether that's 18 and 15 on the x-axis, or that's 3 or 0, whatever. So these are the differences that we're going to take. Now we insert the values, so 4 here and 3 here, and then 3 here and 4 here. And unfortunately, we see that they do not have the same slope. One has a slope of 1.33 and the other one of 0.75. So the answer is no, the vectors are not the same. Now, we need to determine for the second task if vectors are parallel. That means that they lie on the same or parallel lines, regardless of their length or whether they point in the same or opposite direction, because one is true parallel and the other one is anti-parallel. Both of them count as parallel. That means that opposite orientation also count as parallel, as I said. We can check that in two ways. One is to use the method like the dot product or the scalar product of vectors to determine the angle between them. And then the other one is to just find a real number that when multiplied to 1 gives us the second. So most of you will opt for the real number, so I'll go solve for that. But for the angle, just use the formula we mentioned. Or use this method. Formula is on the top right, dot product on the left, and under it are the magnitude of the vectors. But that method takes some time, so we will stick with finding the real number. I do encourage you to use the math thingy, but I won't judge you if you do not, because I'm lazy as well. So anyway, so we set our equation. Vector v must be a multiple of some scalar times vector u. We rewrite that for each individual coordinate, component, whatever. We are gonna isolate c and then equal the two equations we get. So factor out c, equal the two, and now insert the coordinates to see if such a real number exists. So first is the x coordinates is on the left, and then on the right we have the y coordinates. And now we're just gonna like cancel out some stuff. We're gonna get minus 1/2 in the first fraction, and so we'll get that in the second one, meaning that the number does indeed exist, meaning that the vectors are parallel, or to be precise, anti-parallel. So it depends on the definition, but yes, the answer is yes. Now, for the third one, how long is the result, or the resulting vector? Now, I forgot the exact wording, but basically we add to vector v a 3 times elongated vector u. Here are the vectors, and here is the math problem written out. So basically vector v plus 3 times vector u, and we get this. Now I'll use unit vectors to solve this because it's slightly more mathy for the Minitest. So 2i plus 2j plus 3 times bracket 1i plus 3j. And now we just like multiply this one to each of these two because that's simple rules. Oh, yeah. I multiply. Am I dumb? I am, yes. I multiply to each of them. And now I'll just add those together with the same unit vector. So I vector is here, j vector is here. These two together give us a 5. These two give us 11. So we get 5i plus 11j. And now to just write it as a vector, the resulting vector is r511. Nice. Now to determine the length, we will use Pythagorean theorem. we're gonna take the square of the first one and then the square of the second one, add them together, take a square root, we get roughly 12.08. And that is the magnitude of our resulting vector. So if we add these two vectors, like, what's that? 2, 2, and a 1, 3 should be like this, I think. Basically, yeah. This vector here, that is the result of this addition. Oh yeah, this one should be like 3 times longer as well. This result is 12.08 unit vectors long. Of course, there's unit vectors along the normal axis that are like I, J, etc. But you can also get a unit vector of the smaller ones. So the unit vector containing the direction of this R vector would be, I don't know, some kind of RU vector, which is basically 12.08 of them comprise vector R, basically. That's it. Thank you so much for tuning into today's Minitest. I hope it went well, and I'll see you all next time. Bye!